Okay, so it's past. I think we'll kick off.
Yep.
I will start. Welcome everybody. I will introduce the panel to you first. We've got myself. I'm Sam Boshier, Marketing Manager for Hamworthy Heating. Joining us, we've also got Chris Caton, Head of Commercial Product Management for Groupe Atlantic UK, ROI North America, who is the parent company of Hamworthy Heating. Chris is responsible for the maintenance of our product ranges, preparations for new heating solutions to meet the changing landscape that we're facing at the moment. And then we've also got Crystal Croft joining us, who is Project Director for Decarbonisation for Groupe Atlantic UK, ROI in North America. Crystal started a career as a chemist in the petrochemical industry and has held various R&D, project management and commercial roles before joining Groupe Atlantic. Crystal led the innovation team looking at new technologies and the early development of products before being appointed her current role as Project Director of Decarbonisation. So she manages a portfolio of different projects for domestic and commercial boilers, as well as advanced development of low carbon technologies. So we're here today to talk about hydrogen, something we've all been hearing a lot about in the news. So I'll introduce a little bit about who we are. Hamworthy Heating, so we're a British commercial boiler manufacturer. We design, test, manufacture and source energy efficient commercial heating, hot water, renewable solutions, and we supply buildings right across the UK. Our roots date back to 1914. We were set up by two brothers down in Poole, Dorset, and we've been going for obviously more than 100 years now. Since 2008, we've been part of Groupe Atlantic, and we're a part of their growing UK division. Just to give you an overview of Groupe Atlantic in a few figures, so we've got 10,000 employees across the globe, 28 industrial sites, 2.2 billion euros in turnover. We have a commercial presence on 4 continents, and we produce about 8 million devices per year under 17 brands. So that's a little bit about who we all are. What are we going to cover today? So we're going to look at the challenge we face with hydrogen. We're going to look at the recent heat and building strategy and what was covered in that and what it means for heating. We're going to look at the methods of production and distribution of hydrogen. We're going to look at the terminology and types of hydrogen. We're going to look at the differences between commercial and domestic, and then what might we see as the future mix of heating. So I'm going to be moderating the session. Please feel free to put any questions in the Q&A, and I'll be keeping an eye on that, and I'll interject so that we can ask questions as we go through, or you can save it to the end. Either way, our panel's happy to take questions throughout. So I'm going to pass over to Crystal to start off and kick off with the challenge.
Thank you, Sam. So, well, the key challenge really is to address the climate change. So, as you know, 11,000 of scientists have been endorsing research saying that the world is facing a climate emergency. So why is it important? Well, it's important for the planet, of course, but as boiler suppliers, what is our role into it? Well, something we need to know is that, in fact, 25% of the total energy is required at the moment to make building hot and also prepare some domestic hot water. So we're talking about 25% of the total energy is for heating. Now, as part of that, there's also 15% of emission are created by the same activity. So now, while the things have been getting better, and since the 1990s, we have seen the increase in efficiency for the appliances, but also the efficiency in terms of the insulation of the house and the properties and commercial building. There's still plenty of things to do. So what we're going now is the legislation, and everything is going towards the reduction in carbon emission. And everybody has been hearing about net zero by 2050. So what it does mean is that we need to find a balance between the amount of greenhouse gases produced and also about the amount removed from the atmosphere. So with the quantity of energy used into heating for commercial domestic application, it's of course something that we need to look at. So there's something about reducing the demand, it's about reducing the activity which are carbon intensive, but also is to look about renewable and other low carbon really options and power generation. So the target is very, very challenging, we have to say. So we need to get prepared to do so. And hydrogen is one of the things that we need to consider. So if you go to the next slide.
So yeah, as we go through this presentation, what we're going to do is look at what the different technologies are that give us that ultimately net zero. The presentation is focused heavily on hydrogen, but we've got to also acknowledge the fact that there's other sort of energy sources and technologies that have been highlighted by government and all the recent publications that tell us one story, which is that there's going to be a mix of those technologies going forward at different times in the roadmap towards net zero. And in that, we're going to see electrification, which is more electric products, including things like heat pumps, which you hear a lot about. Hydrogen is absolutely still under consideration as to how that's going to play a role in the decarbonisation of heating in the future, and also a big focus on heat networks, which of course can have heat coming from either of the two sort of energy sources we mentioned there. Okay.
So I think one of the big questions people asking is why hydrogen? So basically, why is everybody talking about hydrogen? Well, it's kind of easy and difficult at the same time. So hydrogen is a clean gas. So when you burn hydrogen, at the point of combustion, you do not produce any CO2. So when it's burned, so it can be transported like natural gas. Of course, there is some attention needed in terms of the pipe work required, and a lot of work has been already done into the UK, especially around Leeds and other area with the H21 project, for example, when they have been looking about all the materials, the pipeline, the metering and everything to make sure that hydrogen is suitable to be transported into the current pipeline or into new generation. Now, hydrogen basically is very similar in many ways to all the other flammable gases. It is non-toxic, is non-carcinogenic, and is a non-scheduled chemical. Now, when people are talking about hydrogen, very often people say, well, there's something new. Well, in fact, hydrogen by itself is not something new. It has been exploited safely into the chemical industry, for example, for decades. And as per today, there's about 50 million tons produced worldwide every year. So it's not something which is completely new. What is new is probably the scale we want to apply it to, and also some of the sector we want to apply it to. So that's really the key point. So if we look at the next slide about the difference, how does hydrogen compare to natural gas? Well, as I say, there's quite a number of things which are similar, but there are some kind of interesting differences. So when we talk about combustion, one of the key area is the flame the flame speed. So when you look about hydrogen, the flame speed is much higher than the flame of the natural gas. What does it mean? So when you have a flame into a boiler, the length of the flame is really the resistance of two things. In one is the speed of the gas going through the burner, and then the flame speed going to the other direction. Now, one of the key questions people ask is, say, can you put hydrogen into a natural gas boiler? Well, not easily or not without any conversion. Because in this case, what will happen is that if you're using exactly the same burner for a premix system, what's going to happen is the flame will go backwards because of the difference in speed between the natural gas and the hydrogen. So that is very important. So when we're talking about burner or boiler for the future, the burner is a key element that needs to be looked at in terms of the transition to a hydrogen combustion system. The other area also is the flammability range. So that's the range when, in fact, the gas can inflame or can burn when combined with oxygen or with air. And what you can see is the flammability range of hydrogen is much larger than it is today with natural gas. The density of the gas is very different as well. So hydrogen is not a very dense gas, and the heated value per cubic meter is lower as well. So now when we look about the comparison, we need to be careful because, in fact, by mass, the calorific value of hydrogen is much bigger than natural gas. However, when we talk about volume, it's less because of the difference in density. Ignition temperature are also different, and ignition energy is different too. So what it does mean is, despite it's still a flammable gas, there's a number of things that we need to think about when we're talking about hydrogen combustions. And it's something which technically we can completely achieve. It's not something which is impossible. In fact, plenty of people are already working on hydrogen boilers and making them happen. But we have to take into account. So when people ask, can I use the same appliance and put some hydrogen into it? The answer is simply no, as it is today, because you need to have a conversion kit, as you will have in two different. One other difference as well is that you cannot see the flame for hydrogen combustion, so it's not very visible at all if you try to look at the combustion. And when it's inside a boiler, you cannot see the flame using the ionization system. So there will be new technology to make the detection of the flame into a combustion system. That is, into a nutshell, the difference between the two. But as I say, it's completely resolvable, technically speaking.
And Crystal, can I ask you a question about NOx emissions from using hydrogen?
Oh, very good point. Yes, in terms of the NOx, so when we talk about combustion, NOx is really one of the side effects of all the combustion systems. So when you burn natural gas or hydrogen, you will always have some NOx production. Now, what was interesting is initially people thought that with hydrogen, the NOx level will be much higher, or higher, maybe not much higher, but will be higher because of the temperature of the flame of hydrogen being higher. So because there is a direct correlation between the CO2 emission, the NOx emission and the temperature of the flame. However, the combustion of hydrogen means that we use a different ratio of gas and air. And because of that, in fact, the temperature of the flame is lower. And from everything we've seen so far, the NOx emission using hydrogen are lower than what we have seen on natural gas, which is extremely promising.
We have had a question in about hydrogen to the gas grid, but we will be covering that about distribution later. So I'll ask that question when we get into that section, okay?
Thank you very much, yes. So now, why is it interesting to continue with hydrogen? Well, one of the things is we can utilize the existing network. So that is something very positive. Of course, they are subject to upgrading places. So what we're seeing, for example, is what more and more polyethylene pipeline used everywhere, which are compatible with hydrogen. So what it also means, the second point, is the little change to the home heating system. So when we talk about boilers, it means that hydrogen boilers, it means that overall the customer won't have any really big difference into the way they run their appliances and the way they run their heating or domestic hot water into their home. So there's a lot of question at the moment in the news and comments about the news about the use of heat pumps and the change of temperature system. When we talk about an hydrogen boiler, it's still a boiler. So this is something which is quite important for some of the customers. So if you click more, thank you. The other things as well is require minimal upskilling. So when we look about the installer base, an hydrogen boiler will, of course, we will have some differences, and of course there will be training required. However, what will be really important to remember is the difference is minimum compared to other heating appliances like heat pump, when the change for installer will be probably more significant. And lastly, the benefit of heat pump is you can store, so compared to a heat pump or other system, hydrogen, you can store it. So you can have the capacity to cope with large fluctuation in demand because of the storage of hydrogen. So this is another area which is a benefit. So when we look about what hydrogen could be bringing in the future, that's a big benefit. Now, a lot of people say, well, if it's so good, why we didn't do it before? Well, I think one of the reasons is because hydrogen doesn't really exist into the natural state. It has to be manufactured. So we come back on the manufacturing in a while. But while natural gas is extracted very easily and easily put into the system, I think hydrogen was more expensive because of the scale we were talking about. And so that's why we're going from a system which was natural gas with a lot of exploration, a huge quantity of gas available. And now we go into another system. And what we need really to develop is all the supply chain and everything to make it absolutely economically viable for everyone. But the potential is absolutely there.
Okay, so we're going to move on a little bit into the sort of the government strategy and what we've seen what announcements we've seen over the last few months, pushing us towards on the pathway to net zero. So, towards the back end of the last year, so 2020, we did see quite a lot of announcements from government. So we saw the 10-point plan. We saw the Powering the Net Zero Future, which was also a government white paper backing up the 10-point plan. And what both these documents did is they started to spell out the different methods that government want to sort of pursue to take us on that pathway. So in the 10-point plan, we saw there was a big focus on electrification, which we've already mentioned. There was a focus on hydrogen potentially playing a part in the future as well. And it also broke that down into hydrogen will play a part in industry, in aviation, in transport, and also potentially in heating as well. So no policy in either of these documents, but they did start to give us a flavour really for what government were thinking the future will look like. The white paper then demonstrated a little bit more detail, but not really the policy we were looking for in terms of direction. As part of the pathway to net zero, when we put that into sort of a legally binding in the Paris Agreement, we had to have an independent body, which is the Climate Change Committee, who were also looking at the methods we were looking at to get to that 2050 deadline, if they thought we were being ambitious enough as a government, and also the progress we were making in that period. This is the sixth budget, which was published after these two documents at the end of last year. And while the direction is the same as the 10-point plan, it's got much more ambitious targets. So it's about pushing the drive towards net zero much more hard than government were initially planning to do. Off the back of that, we did then see some further announcements aligning a little bit more the government plans with the sixth carbon budget. Then more recently, this year, over the summer of this year, back end of summer, we saw the hydrogen strategy released from government. Now, what that did is started to demonstrate how hydrogen is going to be used on our pathway, what it's going to be fundamentally used for, and how we're going to use it. So it was really focused around the infrastructure we've got in place and how hydrogen can be used for those different applications. The strategy really said, yeah, we're going to be using hydrogen for transport. We're going to be using it for heavy industry, so for big furnaces, for things like glass production, brick production, and steel as well. But what it did do is it said, and we're still going to continue looking at how hydrogen could play a part in the decarbonisation of heating as well. So less sort of concrete in terms of how it will play a part in the hydrogen future. And then more recently, if you can just do it again, Sam, we've had the heat and building strategy. So the heat and building strategy, again, I apologise for using the word pathway so many times, but it does start to really give us a good understanding about how we're going to use, how we're going to decarbonise heating in buildings, so new build, retrofit, right through to sort of really the early 2040s and beyond. And what that starts to do is electric's going to be there, and it says a few commitments around what hydrogen is going to look like and when some key decisions are going to be made. And I'll give a few more dates on that a little bit shortly. Next slide, please. So we've been focusing most on the heat and building strategy because it's the most recent publication, and it gives us some more, like I say, some more concrete almost dates in terms of how we're working forward. What we're really looking for from government is policy about when things are going to happen rather than sort of ambitions, which is what the strategies are laid out to do. So it was published in October this year, so spending a lot of time reading that and basically pulling out how that relates to our business and what the product of the future looks like in terms of the technologies you're going to see. It really makes a bold statement that all heating buildings needs to be decarbonised. So that's the ambition. It says that net zero means gradually but completely moving away from fossil fuels for heating by 2035. So one of the dates within there is 2035, no natural gas. So that's, obviously on the horizon that we need to be very aware of. Government will make major strategic decisions on the role for hydrogen for heat by 2026, following continued trials. So what that's saying is, and that's what I referred to on the previous slide, is that hydrogen is still under investigation for how that's going to play part in the decarbonisation of heating. We believe, as we'll say all the way through this presentation, that future is made up of different technologies, and hydrogen will be absolutely one of those parts, one of those pieces of the jigsaw that takes us forward. And what we know from this as well is energy efficient, low carbon heat will only succeed if cost comes down of both the appliances and also the cost to operate them as well, to make sure we don't fall into any unintended traps of things like fuel poverty, and people can afford to heat their homes with the technology that they're presented with, and that really is a big focus of this document. So the ambition before we get to hydrogen is 600,000 heat pumps. The ambition is that 300,000 of those are manufactured in the UK, and the ambition is that the cost of those appliances comes down to something that's affordable for the typical house and business as well. And the same will apply to hydrogen as well. So this quote is directly from the Heat and Building Strategy, but really succinctly sort of explains what the plan is. Future is likely to see a mix of low carbon technologies used for heating, electrification of heat for buildings using hydronic heat pumps, heat networks, and potentially switching natural gas in the grid to low carbon hydrogen. So the word potentially sort of does really spell out that we're waiting for that 2026 date to come so that we can make government a decision on what that future is going to look like, what role hydrogen will play. Now, of course, we know that this 2026 deadline is out there, so we've got to work hard in the background to make that, should that come to fruition, we've got the product that's ready to go, and we know we can achieve the the efficient and cost-effective product that people will be looking for, and not, of course, waiting for that 2026 until we start developing. So in the background, there's a lot going on. And also announcements at the same time, lots of consultations and announcements. So one particular is that 2 billion in funding across domestic and non-domestic schemes. So what that looks like is 1.2 billion, will be invested in public sector buildings. So that can be from anything from small residency stuff, social housing, up to big commercial properties like libraries, museums, and council type properties as well. Also in there's 300 million for district heating. So hydrogen could play a big part in heating district heating schemes in the future. And then the remainder of all that is really focused around what happens in the domestic world around migrating from gas boilers to the future technologies as well. So therefore, electrification is a big part of the vision, and we've got to acknowledge that. And then, like I say, we also believe that hydrogen will be a big part of the future as well, more in a longer term sort of approach. And then just before that, I mentioned previously, so I'll just quickly mention the UK hydrogen strategy. So what that was doing was really looking at the infrastructure, what's in place, and how hydrogen could be transported around and what industries it's going to go into. If we just look at heating in particular, then as Crystal said previously, in Leeds, where we've got one of our offices, we've just had the gas mains replaced there for the sort of composite materials that they're going to be using in the future, which are capable of hydrogen. So Leeds has got an ambition to be operating on hydrogen by 2030. 33, I think it is, which we either do or don't believe that's going to happen. But they're certainly putting the investment in to get the infrastructure in place so that it's ready to roll, as it were. And then when we wrote this slide, it was what's next, but really it's what's happening now, because this week there's COP26 in Glasgow, where there's already been big announcements about wanting to reduce the amount of methane emissions by 2030. So it was by 30% by 2030, and the US and the EU, and I think nearly it's open to the other 200 countries as well to sign up to that, to really cut the methane emissions that each of those countries are throwing out. So in summary, at the end of this week, it's going to be really interesting to see all the commitments that have been made, and then that really we do expect to start see driving policy, which could be around things like hydrogen ready boilers, and then moves us towards that 2026 when hydrogen could be confirmed as a rollout into the grid later on in the 2030s. Okay.
Thank you. And now if we're going a bit about hydrogen production, because the numbers of people are asking about where and how hydrogen is made. So we are not ourselves, of course, making hydrogen, but we will be a keen user of hydrogen. So we need to understand where this hydrogen is going to come from. As I said before, hydrogen cannot be extracted from anywhere. It has to be made. And one of the most ancient way of doing hydrogen is what we call the brown or the black hydrogen. And basically the color refers to the way of making it. So one of the dirtiest way really of making hydrogen is to use coal and to use a process which is going to crack and to make some syngas. And really this is really polluting, because by these techniques, in fact, what you see going out is really the CO2. So in fact, you don't win anything, because as you're using coal in the system, you're making hydrogen, but you're also making an awful lot of CO2 as part of the process. And the CO2 is going to the atmosphere. So really, it's not the most environmentally friendly way of making hydrogen. So if we go to the next slide, the next generation, shall I say, is what we call the grey hydrogen. In this case, it's using still fossil fuel, but we're not using coal anymore. We're talking about natural gas and methane. So in this case, again, we have a reaction, and basically we are kind of steaming the natural gas, and we're making CO2 again. But in this case, the CO2, it could be staying, well, emitted to the atmosphere, which is not very good, but it could be turning into a blue hydrogen if the CO2 is captured and sent back to the ground. So when people are talking about a way of making hydrogen, the grey is really one of the starting points. But more importantly, if you click another time, Sam, what we see is that when we go to the blue, it's exactly the same process, but in this case, the CO2 emissions are captured and stored. And you will probably heard about the terms about CCS or CCUS, which is carbon capture, usage and storage. So that's the way that it's mitigating, in fact, the environmental impact. So you're still using methane to start with. You still produce CO2, but the CO2 is captured, and you take the hydrogen to use in whatever application we can consider. As Chris said, there will be question about where you want to use this hydrogen for, but we're going to this in a minute. Finally, another one which is also talked about is the green hydrogen. So the reason it's called green is, in this case, we are using a renewable source to produce it. So, for example, we're talking about electrolysis using renewable electricity, some like wind, solar, or hydro. And in this case, really, you're starting from water and you make the electrolysis. And on one side, you're making oxygen, and the other side, you're making the hydrogen. So in this case, it's much more green, because in fact, you have no carbon emission at all in this process when you do that. Now, one of the other color, I don't know if you heard of the color about hydrogen, but we are talking about the pink hydrogen. So the pink is when, in fact, nuclear energy is used to produce hydrogen using electrolyzer. And also you would now maybe hear about the turquoise hydrogen. In this case, it's still using a fuel like methane to start with, but it's got to carbon black rather than CO2. So as you can see, quite a range of different colors to be used. But what the government is going is to try to promote the use of green hydrogen, because it's using some extra renewable energy, which is very positive in terms of environmental impact, rather than to use methane. So that's where it's going into. So when we're talking about production and distribution, I think it's going to the next slide, Sam, please. So when we talk about the hydrogen and how it's going to be deployed, so at the moment, as you know, there is a massive gas network which provides gas to all types of property and appliances. I think we're talking about more than 24 million of homes on the gas network. So it just gave you some kind of idea about the size about what we're doing. So now when we talk about the gas appliances, of course, it's easy for us to think only about the gas boilers and appliances, but there's water heaters, there's fires, there are cooking appliances. So when people are thinking about the end of gas, this has massive implication about the comfort and I would say the customs of everybody in terms of how they live into their own home and the impact it's going to have. So what it means, the next point really, is about all these appliances cannot be just dealt in isolation. You need really to look about the house and about what's inside. And now, in fact, the hydrogen will be potentially deployed to replace the natural gas. And what we can say is that the hydrogen is likely to be produced in several regions in industrial cluster. And that does make sense, really, that you're going to have this type of plan. So what are clusters? So if I go to the next slide. At the moment, if you look about the carbon emission in the UK, that's the big and small dots that you have around here. So what we can say is, for example, the Humberside area where I'm based today, we are emitting about 12.4 million tons of CO2 per year, which is absolutely immense. So when you look at that compared to the other area, you still have a lot. And one of the key decisions, of course, will be to start decarbonizing this area. So as Chris said before, when we are using hydrogen, hydrogen is an extremely valuable gas because it can be used in plenty of applications. It could be used in power generation. It can be used into transportation. It could be used into industrial chemical application. It could be used in heating. So there's plenty of things that can be used for hydrogen. So where is the best use of hydrogen when we start? So the government has announced that they wanted to do a lot of investment. So if you click again, I think there's probably something about the investment coming through. But you have all numbers of this project here coming around. So you have H100 in Fife in Scotland. You have INET in the Liverpool-Manchester area. You have Humber Zero into the Humber area, H21 in Leeds, etc. So you have a numbers of this project there trying to tackle the big CO2 emissions. And what is going to happen is you have what I call the project union, which is really to try to have area with production of hydrogen, if possible green or at least blue. So you're going to have some kind of introduction of hydrogen production in the UK. I've probably seen the news recently when Boris Johnson has been saying that we want the UK to be really the point of the worldwide expert into hydrogen production. So this is something that needs to be pushed. And what will going to happen is when this kind of capacity starts to go to the ground, it will of course have implication about the use. It will be of course having the impact on the cost. At the moment, numbers of people are asking about the cost of hydrogen versus natural gas. We don't know exactly because we're not the gas suppliers, but what is very clear is that the comparative price of the two gas is going to change with time. So whilst the natural gas, as you've seen in the recent weeks, can go up, it's very likely that the hydrogen cost will go down because of the increased capacity. So the government have been announcing as part of the UK strategy that they target to have 5 gigawatt of hydrogen by 2035. So that seems a lot, but in the same time, it's about 15% of the current demand about what we need in terms of the gas demand. So there's plenty of things that will happen. We know that plenty of projects are going on, and this is very positive in terms of the numbers of jobs and development of skills in terms of the hydrogen economy into the country.
Thanks, Crystal. I'm just going to, hopefully that answers the first question we had in was about hydrogen injection into the gas grid and whether it will be injected at several points around the UK or localised. So hopefully that covers when we talk about the clusters.
Yes.
The other question.
Yes, there will be 2 types. So one of the things that probably we can say is there is a first step, which will be probably the introduction of up to 20% of hydrogen into the grid. So this is something that is currently discussed, and I think we're going to come again in next 2 slides, and then there will be the 100% hydrogen. But to make that happen, you need to be close to a production center of hydrogen, hence the clusters, yes.
Yeah, brilliant. Another question we've had in is it envisaged that hydrogen boilers could be a replacement for oil boilers for off-gas grid rural properties, or is it not practical to locally deliver and store on site?
I will think it will be quite difficult. I'm not saying it's impossible, but having cylinders of hydrogen on the back of your house is probably more difficult than to have oil. So at the moment, I have not heard any plan for off-grid to go into hydrogen. I think there will be other solutions that probably Chris know more about that, but there is still biogas, there will be heat pumps property. Off-grid, it will be probably quite difficult.
Yeah, I'd agree. I think the oil will be replaced by the bio LPG and also bio oils as well. I think hydrogen locally for off-grid is going to be very difficult.
Yes.
Thank you. And then another question, Chris, has been more for you. I think back on one of your slides, we talked about a ban on natural gas boilers from 25. Someone's asking, do you know whereabouts that was in the heat and building strategy? We might have to come back to that. And
I think it's 2035 was natural gas, end of natural gas essentially, and I think this is what we're presenting today is what we think is going to happen, not what we want to happen. But I think that will push out a little bit more. Also, the heat and building strategy does talk about the end of LPG and oil, so off grid. It sort of categorizes it as off grid from 2026 for commercial or non-domestic, and then a little bit further out for non-domestic as well. That is, I can't remember the page numbers, but if you want to give Sammy details, I'll happily sort of send through a bit of guidance on where that is. It's in the first summary section, I know that much.
It's been Chris's nighttime reading for the last few weeks, isn't it? A week.
Definitely.
Okay, great, thank you. If keep your questions coming in, and we'll keep answering them as we go through.
So yes, I think what I want now to explain is about what we call hydrogen boilers, hydrogen-ready boilers, because there's plenty of announcements related to these different categories. So if we go a little bit more into what we call them. So there are different ways of working with hydrogen. So the first one really is the 20% blend. So in this case, it's a boiler which is compatible with a 20% blend. So it's 20% of hydrogen and 80% of methane, not LPG. It's really 20%, 80% hydrogen and methane. And basically, what we hope and what is proven so far is in fact that existing appliances, when I say has been in the market for less than 10 years, are already compatible with them without any modification. So how this was proven, we were part of the iDeploy project, which was a government-based funded project, which was held at the University of Kiel. And the plan was to propose an injection of 20% of hydrogen into the small network of about 100 home plus residential area for students and some commercial boilers. And the point of this project, iDeploy, was to demonstrate that when you inject up to 20% hydrogen, the appliances are still working as they are. And when I'm talking about appliances, I'm talking about boilers, I'm talking about cookers, I'm talking about fireplaces. So this was a very key project. It's just completed a few months ago. So we were partners with this. So we have been testing a number of our boilers on the site, and we will continue to do more because we have, as you know, we have a wide range of boilers, both domestic and commercial. So we will continue to work on that. But the first indication means that our current product, are compatible with a 20% blend. Now, the next point on this one, if I may, is that when we replace 20% of hydrogen, we can reduce the carbon emission by 7%. So I know you say, well, it doesn't seem that is as big as we thought because it's 20% and 7. This is linked to the difference in density, calorific value, and etc. So that's why we went for 20 to 7. But overall, when you think about the saving, if we're talking about 2050, we're going to save the equivalent of 120 million of CO2 equivalent if we were going to implement this. So this is really a low regret strategy. So it is very expected that the government and the gas network will be very keen to start injecting 20% of hydrogen when this is deemed safe and when the kind of all the case has been done to make it happen. So the next round is what we call hydrogen ready. So what is an hydrogen ready boiler? It's an hydrogen ready because it's going to leave the factory as a natural gas boiler. So, and it will be converted on the field the day that the pipeline is going to be converted from natural gas to hydrogen. And this will happen using a conversion kit. So this is not going to say, at the moment, technically speaking, there is not a chance to have a boiler capable to run on natural gas and hydrogen without any change at all. So there will be some change to be made onto these appliances. Now, what we are likely to expect is we think that the government is very likely to make mandatory the introduction of hydrogen-ready boiler by 2026 for domestic boilers. This is now subject to consultation, which is going to happen by the end of the year or maybe early next year, but we really expect this to happen. Also, this hydrogen-ready boiler will, of course, also work under 20%. So that's phase one. So that's when you will start, in fact, having your boilers put into the field, put with customers, ready to be converted the day that is going to happen. And then the third phase is the 100% hydrogen boilers. And in this case, they will be made as hydrogen boilers in the factory and will live as they are and will be installed in a house with already access to an hydrogen network. So that's the three really hydrogen boilers we're talking about. A 20% compatible, 100% hydrogen. So one of the key things on that is not going to happen with people just doing DIY on their back garden. Everything related to hydrogen is really about the safety. So we need to satisfy the Gas Safety Management Regulation, or GSMR. And what's going to happen now is the legislation needs to be changed to be updated for the 20% mix. There will be other changes as well onto the gas distribution network in terms of the gas pressure, etc., the metering, the everything. But we also need to comply with a number of standards, such as the EN 437 or EN 15502, in terms of everything required to make it work. So there will be new gas category, there will be new limit gases, and there will be also new test and recertification for doing that. So at the moment, the safety is priority number one on the hydrogen.
Can I just add there as well, sort of from experience talking with consultants, with clients, and anybody who's got a sort of a general question about hydrogen, I find it's really sort of easy to get the fundamentals down first. So if you can get across these three different types or different conversations about hydrogen that you're likely to have, you can have a much more sort of fruitful conversation with those people who are interested in the topic but don't know that it can go off in different directions.
Absolutely, and it's fair to say that because of the implication of moving to hydrogen, it's a very well regulated system. So all the safety elements are extremely critical. So before applying to anything, you need to have the health and safety executive on board. You need to do a lot of work to make sure that the case is safe. So I know that a number of people think about, well, hydrogen, they hear it's about very flammable, but natural gas is extremely flammable too. That's why it's in the gas boiler to start with. So there's plenty of things to do there. And you can be reassured that we are working with the best people to make sure that everything we're doing will be at the almost safety.
So we've put a section here on commercial versus domestic. And the reason we've done that is because it's difficult to have those conversations sometimes with people wanting to understand more about hydrogen, but also people who are involved in the sort of R&D and the development and things like that as well. Because what we need to remember is that there is one gas grid in the UK. So if you're if you go to the next slide for it, Sam. If you just click through a couple. Thank you. So in the UK, we've got a single gas grid, and that can be sort of refined by region potentially if you look at what Christelle was presenting earlier on. But on that one grid in one region, you've got a number of appliances. Everything is supplied from it. So on there, you've got domestic appliances, you've got commercial boiler appliances, you've got decorative fires, catering, so hobs, ovens, all working on that same gas grid. So if anything is to change to either a blend or to hydrogen ready or to 100% hydrogen operation, we need to be mindful of the fact that all those appliances are going to change on the same day. If something was to change over, everything would change at the same time. And that's really critical in terms of talking with government, talking with BEIS, when we're trying to sort of help and support them on their journey as well, that they keep that in mind and they're very mindful of that. One point I just wanted to make from where Christelle was talking about the blend a little bit earlier, which is an 80-20 blend, so 80% methane, 20% hydrogen, is that for big gas appliances, big floor standing gas appliances where you've got an adjustable gas air ratio on the valve, what we would need to do, although they're capable of operating on that, it would mean a return visit to commission them to operate on that change of gas as well. So something else to be mindful of. Yes, it is absolutely capable of it, but if you were to operate and change essentially the calorific value of the gas going into it, regardless of if it's got hydrogen in there or not, you need to make sure that the CO levels are correct, it's not toxic in any way, and it's operating safely. So safety has got to be the number one priority in every single step as we go through this as well. So most of the trials that Christelle mentioned, the high deploy, which is the 20% blend, and the high for heat, which is looking at 100% hydrogen operation in the future. At the moment, the development work is being done in the domestic world predominantly, and that's because the amount of hydrogen is much less, so it makes sense to develop those appliances and make sure it's safe and understandable before then that's rolled out for basically appliances that have got a higher volume of gas within them, so therefore the risk sort of increases as well. At the moment, most of the trials and prototypes have been done with the domestic boilers, but if the infrastructure is to change, that will affect the appliances and building that are on the grid. So like I say, it's all those different appliances that would be affected at essentially the same time.
Great, thanks. I've just had another question come in. Will the operating pressure of a hydrogen network differ than that of natural gas?
Christelle, can you answer that?
Yeah, I think there's a number of discussion about that, and our understanding, according to the PAS 4444, is that we are taking the same value at the moment to develop our appliances that we're using on natural gas.
Okay, thank you. Okay, we'll move on. Back to you, Chris, with the timeline.
Yeah, so this is, like I said before, this isn't my timeline. This is the timeline of dates that are in the strategic documents that are coming out and that are our best sort of guess in terms of what the future is going to look like. So in 2020, we saw the hydrogen strategy, which is useful, but not as useful as what followed it, which is the heat and building strategy that came out this summer. If you can click through for us, Sam. That told us that in 2026, there's going to be a decision around what hydrogen looks like for the UK in heating, that is. So we're going to see lots of all the trials should be complete by then. There's an ambition to have a hydrogen village operating by 2026 as well, and that'll be able to sort of enable the safety case to be completed and also a decision to be made on what hydrogen means for us in the future. 2030 is our best guess from what we can see in the documents about when we're going to see hydrogen blend in the grid. So it'll be late 20s to 2030. And like we say, all our appliances will be able to operate on that. Just we need to be mindful of the fact that they may need recommissioning. And that's not unique to us. That's unique to any big commercial appliance that's got adjustable gas air ratio. And then in 2035, the date we've mentioned already, which is the ambition of the heat and building strategy to have no natural gas, no methane within the grid in the UK. So a constant theme throughout this, and I will say that we through all our published articles that we've done from GA UK and also through Hamworthy as well, we've always sort of focused on the fact we think the future is going to be a mix of the different technologies, and that's been backed up now by what we're seeing from government. To some extent, are they hedging the bets? Absolutely, I think they are, because we don't know. I don't think there's any single silver bullet that's going to answer the question of heating and decarbonisation of heating in the future. But through the use of different technologies, then we can achieve that. And that's back to the core electrification and hydrogen as well. We include heat networks in there because although it's not an energy source, it's a different method of distribution of heat rather than just a single appliance on a property. And the investment we're seeing in heat networks tells us that that's going to be a big part of our future in densely populated areas like the city centres and other urban areas like that.
I just have a question on heat networks. What do we think will be the future heat source for heat networks?
The investment that we've seen in the recent publications, so the 330 plus million that I mentioned a little bit earlier on, is focused very heavily on low carbon heat sources for district heating. And what that can be, it can be waste heat from energy, from power stations, from industry, and also ground source heat pumps are playing quite a decent role in the sort of the design stages at the moment, while people look at those in conjunction with ambient loops. So where you've got several low carbon heat sources, several stages of heat pumps, for example, all contributing at different points to a heat network over a district area, not just a single building, to elevate the temperature of those heat networks. So it's going to be again a number of different technologies, or a number of different a number of the same technology on spread out across the heat network to give you that the temperatures that you need, backed up potentially by smaller heat pumps within apartments if that's what's being used, or hydrogen. I do believe could play quite a big part in district heating in the future, because it pushes us towards that big pressure jet type appliance where you can create a big volume of heat that can be efficiently used on a system that's well designed.
Great, thank you. Another question as well about hydrogen and the skills needed. I think, Crystal, you did touch on this, but will there be any different skills needed for engineers working with hydrogen? For example, servicing, installation, will gas safe still apply?
Yeah, I think, well, at the moment it's very difficult to know exactly what the requirements are going to be, because as part of all the project working on hydrogen, some elements are looking for the skills required. So I cannot tell you exactly what is going to be, but of course we will need to continue to do some kind of gas safety system in place. In terms of the skills, the good thing is combustion is still combustion. So whilst I believe that there will be probably some training required to understand the difference about hydrogen, about how to deal with a number of things, overall I think the gap will be manageable. So there will be a lot of activity for this, because you can imagine that if we need to convert millions of homes within a period of time, it means that people, the installers, are going to be extremely busy. So because this is also going to be very localized. As we said before, it's going to be done by clusters. So when you start, for example, if we were talking Liverpool, for example, the area of Liverpool can start to have some of the network being transferred, which means that there will be people having to go and change the appliances or the conversion kit on the appliances, depending what we're talking about, within maybe 48 hours. I don't think that people would take gladly to be off-grid for more than 2 days. So at the moment when we're talking about conversion, and I'm talking about domestic boiler there, but the target is to try to be the conversion from natural gas to hydrogen in less than 2 hours, and hopefully in less than 1. So it means that the level of intervention could be quite quick. But it means in terms of installers, it will be about making sure that it's done safely, that everybody understands the conversion process. So there will be some skill gap, but I think they are manageable.
Great, thank you. So that's the end of our roundtable. If you've got any more questions, please put them in the chat. We've answered the ones that have come in throughout. I have, as Chris mentioned earlier, we do get certain questions about hydrogen-ready boilers, blend. So I put a poll on, just if you want to answer, wondering if you've ever been asked by a client for a hydrogen-ready boiler. As a manufacturer, we've been asked for certain hydrogen-ready, and it's often explaining what the different types mean. So we've got some information on the Hamworthy website that you can go and read more about hydrogen. Pretty much everything we've covered today, but in more detail as an article. Is there anything else, Crystal or Chris, you'd like to add before we finish up?
Just there's a good attendance all the way through, so we really appreciate that. And if you do have any questions in the future, then please reach out to us at Hamworthy, and we'll try and help and support you.
Thank you.
Great, thank you very much. Thanks, Chris. Thanks, Crystal. Thanks everybody for joining us. Enjoy the rest of the BESSA event.